Hello everyone, welcome back to Science with Mr. Fitri. Today we're going to focus in on Earth's interior, the second lesson of our first unit. Now, as you hopefully remember, when I say interior, you know that means the inside. So we're going to look at the inside of Earth today. Two objectives for today's class. Number one, how do geologists learn about Earth's interior? So how do we learn about what's going on within the Earth? And what are the features of Earth's crust, mantle, and core? So we're going to look at those different pieces that we touched upon last time. Vocabulary again. Now, as I mentioned last time, if you need to pause the video to write these down, please do, all right? But I'm going to get through them here. First of all, geology, the science of the earth. Geologist, an expert or student of geology. Pressure, a force pressing on an area. Molten, liquefied by heat. We're going to hear this term quite a bit, okay? So remember, when we talk about something that's molten, it has been heated up and it's made so hot that it's become a liquid, right? Like if you heat up metal to a certain temperature, it will become a liquid. On the flip side, we've got solid, a substance that resists changing shape. We've got liquid, okay, a substance that flows and whose shape, but not volume, can be changed. All right? If you take a cup of water, no matter what vessel you put that in, a bottle, a pot, a cup, a vial, it may change shape, but the volume will remain the same. Gas, matter that conforms to the shape of the container it's in. An example is oxygen or hydrogen. Interior, okay, remember what I just said, this is inside. Exterior, outside. Again, two terms we'll continue to hear throughout this term. And temperature, a measurement of how hot or cold an object is. Okay, so I know this is a lot, all right, but we did talk about most of these in our vocabulary unit. So, I hope you remember. On to objective 1. How do geologists learn about Earth's interior? So, as you can suspect, you can't just look into the center of the Earth, okay? And as I said, geologists can't look into the center of the Earth. So they study it using rock samples and seismic waves. In the pictures there, what you see is a man doing a core sample, all right? Now they're digging down, making like a cylindrical, cut into the earth to see what lies below, all right? So if you look at the picture on the left, you see maybe different types of rock, different types of soil, maybe different minerals. So that's a good way of studying the earth to some extent. Okay? Specifically with these rock samples, all right? We get them in one of two ways. First of all, geologists drill holes and bring up rock. What you just saw in the last picture. Okay? Digging down, finding what rocks are at different depths in the earth. The other way is volcanoes. Volcanoes bring up rock from deep inside of the earth during eruptions. Okay? Now we'll look at volcanoes in the future, but realize that you're not just looking at the volcano as a mountain. The volcano actually goes very deep into the crust and even the mantle of the earth. So when they erupt, when they explode, when they go boom, they can bring up a lot of information for geologists. The other way is seismic waves. Now, this is a brief overview. We'll look quite specifically at seismic waves when we talk about earthquakes in a couple weeks, I'd say. So seismic waves are the vibrations, the movements produced by an earthquake. Geologists study how these waves travel through Earth. What we need to understand about that is that the speed and the paths of these waves give geologists clues about the structure of the Earth. So what you see on the left-hand side, a little GIF, are the three types of waves. We've got P waves, S waves, and surface waves. Each of them act differently. And we'll see this later, but you can see just from the little GIF here that each are doing different things to the Earth. Now scientists are going to use that information to determine maybe, what's the consistency of the Earth below this part of the surface. Okay? What types of rocks are below? What types of maybe minerals? Okay? And that will tell us a lot about the structure. So again, how do geologists learn about Earth's interior? Well, one, they're going to use rock samples and seismic waves. All right, you see a little GIF of seismic waves to the left there. Each are doing different things to the Earth as they pass through it. On the right, you've got a little Minecraft GIF, right? I'm sure that some of you like to play Minecraft. All right, I've played Minecraft in my day. Now, if you think about the Earth like Minecraft, because it really is a very similar, what shall I say, a very similar situation, okay? When you dig in Minecraft, you find iron, you find coal, you find sand and clay and dirt and different types of rocks. You may find diamonds or emeralds. But they differ. You're not always going to find coal. You're not always going to find diamonds. But when you do, you're often going to find them in little sections or pockets. Okay? The Earth operates in a very similar fashion. Okay? And we'll continue to delve into this. Next, what are the features of Earth's crust, mantle, and core? So, Earth's geosphere, all right, the land, is made up of three main layers: a crust, mantle, and core. Now, I include this little GIF of Shrek and Donkey from the movie Shrek, because there's that portion in the movie where Shrek says, ogres are like onions. They have layers. And the Earth is just like that. It is like an onion. It has different layers, but of course the Earth has layers that are different. All right, it's not all onion the whole way through. All right, so let's look at these layers. So what we need to understand, and just like I was saying about the Shrek reference, is that these layers vary, they differ in size, composition, temperature, and pressure. So the deeper you go in the Earth, the greater the pressure and the higher the temperature. Okay? So these are some key things I want you to remember, all right? The layers are different sizes. They're made up of different things. And the deeper you go into Earth, the greater the pressure and the higher the temperature. Okay? Please remember those. Now, the outside of the Earth, all right, the crust. We nickname it the skin of the Earth. Why do we call it the skin of the Earth? Because it's the outside, right? When we look at our friends and family, right, we don't see their bones or their muscles, we see their skin. Same here with the Earth. We don't see the rocky layers of the molten core. We just see the outside soil and rocks and water. So the crust is a layer of solid rock, but it includes dry land, right, where we live, and the ocean floor, the bottom of the ocean. Now, the crust is on average between 5 and 100 kilometers thick. Now you may think, oh, 5 to 100 kilometers, that's pretty big. But when you compare the crust to the other layers and to the rest of the world, or the Earth, it's very thin. Lastly, I want you to remember this by thinking about pizza. I'm sure most of us love pizza. I love pizza. I mostly love cheese. Let's be honest, I love cheese. But with a pizza, the outside of the pizza, the bread part, not where you see the cheese, the bread part around the outside, that is also called the crust. It's the outside portion of the pizza. So think about the crust, the outside of the Earth, as being the crust of pizza, the outside of the pizza. Now, the crust is primarily made up of two types of rock. And this differs between what we call the oceanic crust, the crust of the ocean floor, and the continental crust, all right? The dry land portion of the crust. The oceanic crust is made up of basalt, and the continental crust is made up of granite. Now, when we get to rocks and minerals, we'll talk about why there is a difference here, all right? But primarily it's because the oceanic crust, the crust of the ocean, is much younger than the continental crust. Okay? Now, the elements of Earth's crust. I hoped that we could have talked about this in class, but since this is our video, I just want you to look here at what the crust is made up of. Okay? Primarily, it's made up of oxygen, right, 46.6%. But the second largest element within the crust is silicon, 27.7. And then we've got aluminum, iron, calcium, sodium, potassium, magnesium, and then everything else only makes up about 1.4% of the crust. So just think about that, all right? Think about, how we use these elements. The next, as we go deeper in the earth, we get to the mantle. The mantle is the middle layer of the earth. It is made up of rock that is very hot, but solid. Okay? It's very hot, but solid. It has not become molten. Okay? The mantle is nearly 3,000 kilometers thick, and it has more magnesium and iron than the crust. Now, I don't necessarily want you to remember these, but I do want you to know that the mantle is subdivided, right? Divided again, into 3 additional layers. The lithosphere, the asthenosphere, and the mesosphere. Lastly, at the center of the earth is the core. And like I just said, we call this the center of the earth because it is the center of the earth. Now the core is primarily made up of the metals iron and nickel, and it has a radius. A radius is from one side of a circle to the other. It has a radius of 3,480 kilometers. Now the core is made up of 2 parts. The outer core is a layer of molten metal. Okay, so the outer core is still very hot, so hot that the metal is liquid. However, the inner core is a dense ball of solid metal. Okay? So it's solidified metal, very dense, but also still very hot. So again, with our objectives here, all right, I want you to take away the 3 layers of the earth, the crust, the mantle, and the core. I want you to remember that their sizes are different and what they are made up of is different. And that as you go deeper into the earth, heat or temperature increases, as does pressure. Okay? Some critical components of the earth I'd like you to remember as we go forward. All right. Thanks so much.